All right. Well, my name is Bert Spaan, and there's Jules Schoonman also there. I think it's up to you to start, Jules.
No, you start by introducing yourself.
Oh, that's right. Okay, so welcome to our talk about Allmaps. My name is Bert Spaan. I make computer programs and I make maps. I'm also the co-chair of the IIIF Maps Technical Specification Group.
And my name is Jules Schoonman, and I work at Delft University of Technology Library. And I work on the presentation of our special collections and academic heritage. And geodesy is one of the highlights of our collection, which includes the history of land surveying and map making. And Bert and I collaborated previously on two applications in this exhibition at Panorama Mesdag in The Hague about land surveying in the Netherlands. And in both of these applications that we made, we used digital collections of other institutions, and it made us very aware of the value of bringing these collections together and showing them alongside our collections. And after this project, we discussed how we could continue doing this for other collections, especially digital maps. So we started to wonder whether we could provide a better overview of maps that are digitally available online. We thought that we could maybe make reusable tools that we could use for these kinds of exhibition installations or for other means, use that for displaying these dispersed collections. And we also thought about, when we work on projects like that, it would be very nice if we could bring the data, the enrichments that we create back to the original institutions and bring that and keep that close to the collections. And of course, for all these questions, we thought that IIIF was the right answer. So we started by generating an inventory of digital map collections online, and usually as a subset of larger collection portals. And we quickly realized that there are hundreds of thousands of maps available worldwide. And you can see some examples here in different repositories. So browsing through these portals confirmed the value of bringing these collections together. We noted that there were maps of similar periods, regions, of cities, but they're actually scattered over different institutions and archives. For example, the next slide shows 3 maps from Rotterdam, from where I am presenting. I think one is from Harvard, Princeton, and from the Amsterdam Free University. So, of course, the experiences for viewing these maps is also very different for each of these portals. Some of the collections also offer more advanced browsing experiences. For example, the National Library of Scotland here has a very advanced and different ways to navigate our digital maps. But these applications are usually tailor-made, and they're really made for this specific institution. And they also leave the IIIF framework. So we started wondering, could we make something within the IIIF domain? And this is something that Bert had already been thinking about. Please continue.
All right, yeah, so from 2015 to 2017, I worked at the New York Public Library in New York City on the project called the New York City Space-Time Directory. During this project, I did many things. One of the things I did was work with MapWarper. And MapWarper is a tool that some of you might have seen. It's an open source web-based tool for georeferencing maps. It was originally commissioned by the WebGL, I think more or less 10 years ago. It was one of the first tools that let people do crowdsourced web-based georeferencing projects. And MapWarper is great, but it's by now 10 years old. And as you can see, this is a recent screenshot of the tool. The NYPL has apparently decided that they will stop supporting MapWarper. But MapWarper is not great just because it allowed for crowdsourced dereferencing, but also because It had an API with which you could download all the georeferencing data. So you could get metadata from all the maps that were processed using MapWorper. One of the things I did with this data while in New York was create a tool called Maps by Decade, which was a very easy to use interface to find and explore maps of New York City. You could point your mouse cursor to a very specific street corner, for example, and you could find maps that would depict that very precise geospatial location. When I moved back to the Netherlands after the WebGL, I was thinking of creating something like this for the Netherlands. I briefly worked for the Amsterdam City Archives, and they had done a georeferencing project, but it was very complicated to work with the data from their georeference maps, and also they did not have IIIF. They were using a different system altogether. And other institutions and museums in the Netherlands had completely different systems. That this is what at the same time I met up with Jules, and we thought about how we could use IIIF to create something more interoperable, more universal. Also, MapWorper had, and this is I'm sure one of the reasons why the NYPL has decided to stop supporting it, a big problem, which is that it requires 3 copies of each image. So first of all, of course, there needs to be the original image in the digital collections. This image is then copied to MapWorper server, and there it's processed after it has been dereferenced, and then a warped Duotif is generated, and they are usually very, very large in size. And while at the NYPL, we constantly had to call the IT department to ask for yet a bigger hard drive. However, the process of dereferencing itself just generates a few numbers, contour points that link geospatial coordinates with pixel coordinates, and sometimes a pixel mask with which you can remove the non-cartographic material of an image. So really, to dereference a map and then to warp it, all you need is a very tiny file. It can be a JSON file or CSV file. And luckily with IIIF, the images are already somewhere on a server, and you can request only the portions of the image that you're interested in. So we started thinking about how we could combine this metadata with IIIF to create something that's a little bit more easy to use, and that does not require complex infrastructure and tools like MapServer or GeoServer. One thing that's great about IIIF is that you can request only the parts of an image that you're interested in. For example, there's a map of Rotterdam, and below is a map viewer. So you can see that if I move the map, it knows what IIIF tiles, parts of the image, it needs to download. So if you would combine this with something like WebGL, you could request IIIF tiles, transform them in the browser using WebGL, and warp and draw the geospatial version of the IIIF image right in the browser. So all that's needed is a modern browser with WebGL and a tiny bit of metadata. I am part of the IIIF Maps technical specification group, and in this group we're working on a IIIF extension that will create a standard for to georeference and geotag IIIF images. This specification is not yet finished, but this is how this could look like in the future. This is the metadata needed to georeference and warp a IIIF map. So the first part is that you point, this is a web annotation. So you point the web annotation to a target, which is a IIIF image. Then you select the portion of the image that you're interested in. In this case, it's an SVG selector. So it's a polygon with which you say what part of the image you're going to georeference and warp. And then there's a set of control points that map a geospatial coordinate, the GeoJson point, to a pixel coordinate. And usually we have 3 or 4 of them. You're fine, and you can warp the image and create a geospatial version of the image. Allmaps allows you to point the georeferencing tool to any IIIF URL by using the image URL or manifest URL. And then you can start georeferencing. In this screen, you see the masking tool. So you can create a mask around the image. And then you can place contour points left and right. So left on the original image from IIIF and right on a map, for example, OpenStreetMap or Google Maps. So you can move those points around, and if you need more, you can add more, of course. You can throw them away if you want to. You can also view the web annotation, which is all the metadata that's needed to warp the image right there. And then when you're done, you can view the map on top of, in this case, OpenStreetMap, I think it is. So you can see that it does the warping in the browser. So it loads tiles from IIIF and it renders them in the browser using WebGL. So this diagram shows the core components of Allmaps. First of all, of course, there's a tool for web-based georeferencing, which is what I just showed you. But we're also working on import tools. So for example, if you have a map collection that has already been georeferenced with some other tool, we provide ways that you can import and convert that metadata to something that's compatible with Allmaps. Everything works with this official IIIF extension, which is upcoming. And all the components use this metadata specification to communicate internally. If you georeference a map, we provide a very simple API that allows you to store georeferencing metadata, but you don't need to use our database and API. You can also use all our tools as static websites and use the URL to load annotations or IIIF URLs. So you by no means are locked into using our servers. And then in the end, you can do in-browser map warping, or you can export the warp map using some export tools. So for example, you can generate Duotifs or map tiles or whatever other geospatial format you're interested in. Or you can start curating collections from maps from different institutions and explore and view them together. So this is an example how you can use the Allmaps georeferencing tool. You can load, in this case, a IIIF manifest, and you can start georeferencing. And when you're done, you can point the viewer to the web annotation that's produced by the georeferencing tool. But if you host this annotation somewhere else, of course, that's fine too. You can export to formats like Geojson in this example, which produces the geospatial boundary of the map, which you can then ingest in geospatial indexing tools or databases. So you can create, for example, a website that will, just like Maps by Decade, that you can point to a specific location somewhere, and then it will find the maps that will depict this location. This is another example of a command line tool that we're working on that will load one of the annotations and then convert this to a GDOL script that will create a Geotif. So once you've run this, you can load the Geotif in a GIS system like QGIS, for example, which is shown in this screenshot. Well, now back to you, Jules.
Thanks, Bert. How is Allmaps funded? This is still a bit of a work in progress. The original project plan for Allmaps was written by Bert and I in collaboration with Leiden University Libraries in the Netherlands. And the first development phase has been funded by TU Delft, and additional funding of Leiden and the Dutch National Library is still pending. Similar to Mirador and Universal Viewer, Allmaps could be easily integrated into existing collection portals, and therefore the tool could also be, if it is used, supported by a wider range of institutions. All the components are open source, they use open standards, they are published as static sites, and this all means that we're trying to limit recurring costs for server maintenance. So yes, we're looking for other partners to maybe co-invest in Allmaps. This could be into specific components, like for example, certain exporting tools that are interest for certain partners, or specific futures, or the project as a whole. And we're also thinking of supporting these dynamic services, such as the annotation server, the API that is already running, but how to support that long term. And also in the future, more complex crowdsourcing tools, think of version control, but also authentication. And going back to the beginning, we do prefer to work on projects that are content-based and really aim to bring collections hosted at different institutions together, for example, on the occasion of an exhibition, and to try to combine the software development of Allmaps with a bit of, let's say, curatorial research. And most of what we have shown is available on allmaps.org.
Fabulous. Thank you, Bert and Jules. I think we have 2 minutes here, so maybe I'll ask 2 questions that are in the chat, and you can pick one or both. One is, how many control points do you need, for example, for a map of 1600 to get a satisfying result, because Mercator projection wasn't widespread? And another question is, where do you store the remapping data, like the control points, for access later?
Yeah, to answer the first question, when they're really old maps, sometimes there's no way you can get a really precise warping result. I think in cases like this, and also Allmaps currently only supports very simple transformation algorithms, and the plan is to add more later, like template spline transformations. In some cases, I think there's no way you can get a very accurate warping result, but that's just because the maps are not accurate. So that might be a problem that Allmaps cannot solve. But for most maps, maybe 5, 6, 7 control points are enough, and sometimes maybe more than 10. Second question was where we store the annotations. Was that the question? I think so.
Yeah, I think that's right. Yeah, control points.
Yeah, so well, you can either store them yourself. You can when you're done your referencing, you can download the web annotation with the control points and store it on your own server, on your laptop, wherever. Or you can choose to store it in the Allmaps database using the Allmaps API, and then we take care of it. But then, of course, well, currently somebody else can come and
you can include them in the IIIF manifest.
Oh yeah, of course, that's something you can do too.
Yeah, that's the best.
Yeah.
Okay. Well, thank you. I think we're gonna pause it there. We're right at 20 minutes past the hour. There are a couple other comments. There's a really interesting one I don't think we have time to get into, just about topographical data and 3D visualization. Maybe that is a topic for later intersection between the 3D communities and the IIIF map communities. So we have time to get to the next sessions. I'm going to end it there. I will say very much, again, thanks to Bert and Jules. Thanks everyone for joining us. And yeah, look forward for more sessions later today.
Thank you, Josh.